Welcome back, everybody. Let's finish up Chapter 3. Specifically, let's talk about Section 3.4. We'll talk about how graphs can be misleading at times. And one thing that I'd like to remind you is that we want to have a scientific attitude. And a scientific attitude is all about being skeptical of the data. We want to make sure we can make sense of the data. We don't want to be cynical. There are people out there, of course, who want to mislead us and take advantage of us. That's why we're going to talk about it so that we're prepared. But the vast majority of data that you will encounter in the media is pretty fairly presented. Let's talk a little bit about when that's not the case. So just to introduce this, let's talk a little bit about perceptual distortions. You might remember this photo from Intro Psych. And there's something special about this room that makes these people look so strange. This person looks so small and this person looks enormous, like a giant. But that's a room unlike any room you've probably ever been in. And the dimensions of that room really serve to exploit our perceptual vulnerabilities. So there's nothing straight in this room. This floor really heads down and the ceiling heads down over here. This wall right here is actually much larger, much taller than this wall, and this wall is closer than that corner right there. The bottom line is it doesn't fit anything that we normally see. And thus when we see this, and it kind of looks like something that we normally see, we perceive this person as looking huge. Well, this isn't an intro psych lesson. I just want to let you know that these particular lessons are not lost on statisticians who have ulterior motives. They're going to do various things to exploit the way you see the data. Let's go through a couple examples. Check out this one. It's kind of interesting. It's using a graphic of a dollar bill to show how the spending power of a dollar has changed using 1980 as a baseline. We're saying a dollar equals a dollar back in 1980. And then we want to see how much does that dollar buy in 1990 and in 2006. In 1990, it's only worth about 63 cents, and in 2006, it's only worth about 41 cents. But this statement up here, this question is important. If $1 in 2006 was only worth 41% of what it was worth in 1980, then why is this graphic only 17% of the original size of this graphic? The bottom line is these pictures that we see, these graphics, are out of proportion with the numbers that they're supposed to represent. If in 2006 a dollar is only worth 41 cents, then this graphic should be 41% the size of this graphic. But in reality, it's only 41% of the length that's correct. But we can see that this is so small, it would really take about 5 or more of these dollar bills to make this same size right here. Let me show you what I mean. Here we've got this dollar bill matching up with this dollar bill. Now, if I wanted to take this and just keep like 63% of it, I'd be cutting right around here. You can see right here, this graphic is 63% of this graphic right here. This one's obviously much smaller, so that's misleading. And it gets even worse over here. If I took, again, this dollar bill, and I wanted to only keep about 41% of it, I'd be making a cut right about there. And here we can see this is 41% of this original graphic, not this, which is much, much smaller. So it's showing a misleading type of story when we look at the graphics that were presented originally. We could take those segments that I created and put them into essentially a bar graph. And now we can see that these bills are in proportion with how much their spending power is worth. You'll see a big difference. This tells a very big difference in the story compared to what we see right over here. Let me give you another example in which the data is probably even more misleading. Here we have the same problem, and I want you to be able to kind of put in words what's going on. Let's say I showed you these two graphics, and I asked you to put into words what the problem is. Well, how are we going to troubleshoot it? We can see here that it's essentially showing how many homes have TVs, or this is specifically homes with cable TV, in the year 1980 and the year 2005. 18 million homes in 1980, 73 million in 2005. Well, that's a lot more. And the graphics are showing pictorially that there are a lot more homes with cable TV. But are the graphics in proportion to the numbers? That's what we want to see. So the first thing that I want to check out, and I'll pull up our calculator, move it out of the way, determine what are the relative proportions of these values here. I mean, I want to be able to get a sense of, is 73 million 2 times 18 million, or 3 times 18 million, or 10 times 18 million? Let's just go ahead and figure that out really quickly. So let's take 73 and divide by 18. Let's see how many times 18 will go into 73. It equals about 4. So it's about 4. So for purposes of our discussion, we'll just say about 4 times as many homes have cable TV in 2005 compared to in 1980. Well, the critical question then, is this graphic about 4 times larger than this graphic right here? And I'm sure you'd all agree that that's not the case. So how would we put this into words? On an exam, you might say something like this. The large TV is much greater than 4 times the size of the small TV, yet 73 million is only about 4 times 18 million. So we can see that there's a disconnect between the actual values and the graphics that are being used. Bottom line is that it's misleading. Let's talk about one more thing. We're essentially going to revisit an issue that we talked about before. Remember scaling tricks that we talked about, playing games with this scale? And I showed you this example where essentially just the caps of these bars was captured in this graphic right here. And it's misleading because now it looks like New York has a population maybe 5 times that of LA. Now, technically speaking, you know, the bars are labeled with these numbers in here, so we should be able to figure it out. And that's why your textbook authors say that from a mathematical standpoint, this is perfectly honest. And it's perfectly honest to leave out that 0 point. That said, they do recognize that it can be deceptive. And I'm going to stand by what I told you before, and that is that if you want to create a chart and you want to do it in a fair way, and you don't want to be criticized for the way you do it, you should probably include that 0 point, because now the bars are represented proportionally. Here's another quick example that follows that same problem. This is looking at women as a percentage of all college students, specifically between these years, back to about 1900 or so to somewhere around 2000. And you can see that there's no 0 point over here, and that's going to really embellish these changes in the slope going up or down. So we can see that there looked like there's a huge dip, you know, at this point. Something happened around here. It's probably, you know, because of wartime. And then after World War II, it looks like the population of women in college really went through the roof. And indeed, there is an increase. You know, we can see that there's a decrease here and there is an increase. But the question is it really as dramatic as what we see? When we look at the actual numbers, these are deviations from, you know, at this point, this is around like 47 or so percent, and this is down to about 32%. Well, it almost looks like we're dipping down to 0, doesn't it? Because there's no 0 point. And we're used to this being a 0 point. And this almost looks like it's climbing up to 100%, because that's where we're usually seeing the top part of that graph. Well, if indeed we are looking at percentages that range from 0 to 100, this is how it would be graphed, the exact same data, if our entire scale was represented. And we can see that the numbers are exactly the same, and it still tells the same story, but this might tell it in more of a misleading way. So what's happening in these situations? People are essentially cropping this graphic. So they might crop from the top, crop from the bottom, and then they're essentially expanding the background to kind of fill up some space. And when you expand that background, it's going to embellish these up and down slopes that we see. So I wouldn't agree and say that it's perfectly honest. I think it's actually quite misleading. So you should probably try to stay away from that. All right, that sums things up for section 3.4 and for chapter 3. For now, that is all.